There are many reviews of this portable power station, but the station has even more features, so there is plenty to talk about. I have prepared thoroughly for this review. Today, there will be large-scale tests of the Allpowers R2500 V2 power station. The stated output power is 2.5 kilowatts, but there is already a special feature here. The built-in battery capacity is 1920 watt-hours, and there is a port for connecting an external battery. What I like most about Allpowers is the build quality of their stations, so I will definitely take it apart and see what is inside. A special feature Allpowers is that they don't use very thick nickel strips for welding the internal battery, and such a battery is easier to disassemble and repair if any problem happens with it. I am going to show you a feature right away that I found while working with, and it is quite useful. Right now the station is disconnected from the grid and the phone is charging from it, and there are no issues. Connecting the grid. Just in case, I'm showing that the ripple on the USB outputs is low. And when trying to use the smartphone, it turns out that the smartphone can have a mind of its own. If your all-power stations also have this quirk, be sure to write about it in the comments, and I'll pass this information on to the manufacturer. End of filming the video. I finally connected to this station via CAN. It also features dedicated ports that allow you to easily connect external batteries for extended power. There are CAN high and CAN low pins there. The data exchange rate is 125 kilobits per second. The protocol here is proprietary, and I managed to decode part of this protocol. And to do that, I had to use artificial intelligence. Now, from this station, without even turning on Bluetooth or Wi-Fi, you can get information like this. And then this information can be used in home assistant automation. I'll definitely leave a link to the program in the description under the video. The station has a fairly simple design in the style of Minecraft. There's a small indentation on the surface. This is so that items wouldn't fall off it while it's moving. And also so that you can place an expansion battery on top and it will also hold securely. On the left station, there is an AC input, a circuit breaker, and a solar panel. Input: the voltage range that the solar input can work with panels is from 12 to 150 V. And this is the largest voltage range in similar devices. That is, you can recharge the station from various DC sources and even connect several series-connected stationary solar panels. The maximum input power here is 1000. Whoa, but the current is only 13 amps. From an LFP battery at 25.6 volts, the station takes only 340 watts through this input. And at voltages from 12 to 25 V, there is a current limit of 8A. And such a limit is the norm for such devices, and is done so as not to burn out. The cigarette lighter in cars. And at a voltage of 26 volts and higher, there is a limit of 13A, and at an input voltage of 50 V, the station will take almost 700 watts. I remind you that first and foremost, the energy supplied from the solar panel input is used. It is used for charging the battery and for powering the load. The AC input also has its peculiarities. Pay attention to the input voltage range and the 10 amp current limit. The documentation states that the station can draw a maximum of 2000 watts through this input, and no more. Oil heater has 3 heating levels, that which it consumes 600, 900, and 1500 watts. Right now, the station is charging at a power of 1940 watts. I'm turning the heater on to the first level. It consumes 600 watts, and the station has reduced the battery charging power to 1400 W. I increased the load to 900 W, and now 1000 W is going to the battery. I increased the load to 1500 watts, and 500 watts is going to the battery. But from the city grid, at this time, the station is drawing exactly 2000 watts. And what will happen if the load of the station in bypass mode exceeds 2000 watts? And here I already used several devices. As soon as the load exceeded 2000 watts, the station switched to powering from the batteries. Also, note the noise level of 65 decibels. This noise is audible, fine if you are nearby, but the station is not too noisy, especially since you won't often load it to 2.5. kW. So in conclusion, the station passes no more than 2000 W through itself in bypass mode from the city grid. If you exceed load of 2.5 kilowatts, the station will work for a few seconds and then the protection will trigger. The AC input voltage is stated to be from 220 to 240 versus, let's check this. And for this, I will use an old auto transformer. It turned out that at a voltage of 260 volts, the station still takes electricity from the grid, and when the grid voltage drops below 190 volts, the station switches to battery power, and it reconnects to the grid when the voltage rises above 200 volts. So the input voltage range is, the station is from 200 to 260 V at the station's output when operating on batteries. We have a pure sine wave, and the station, like most similar devices, has a UPS. This mode is quite efficient. The switching process happens very quickly, typically taking only around 10 milliseconds to complete. When you are operating on battery power, there's no neutral connection at the output. Consequently, phase-dependent boilers will simply not function correctly unless you provide a forced grounding of the output. On the other side of the station, there are two ports for connecting external batteries. An MX215 connector is used here. Such connectors can be found on AliExpress, and try to connect a third-party battery, but I don't know for sure yet which connector will work for this. If you have this information, please write it in the comments. When you turn on the station, you'll see voltage from the battery on the power outputs of this connector. And one of the main features of this station is the fact that it uses a LiFePO₄ rechargeable battery with 15 cells and a nominal voltage of 48 volts inside. And most manufacturers of third-party batteries make batteries with a 16S configuration and a nominal voltage of 51.2 volts. So using a third-party battery for increasing capacity here is more complicated than on other similar devices. And this is about increasing capacity in such a way that this third-party battery also charges from the station. Although nothing stops you from buying a separate charger and a battery 51.2 volts and powering the station through the solar panel port. Battery. And now about the capacity of the built-in battery. To reduce the power consumption of the inverter, I will do a quick discharge. I will discharge it into a water heater with a power of 1900 West. I did 4 such tests, and the station consistently delivered about 1700 watt-hours. During this test, another feature was revealed. When discharging through the AC outlets, the station turns off these outlets at 5% remaining capacity. But the DC and USB outputs still work. You can use them to charge your smartphone or laptop because through these outputs, the station will provide almost another 100 watts. This is another cool feature of these stations. You won't be able to cook food anymore, but you will still have energy for communication. Wi-Fi and Bluetooth are turned on here by holding the USB button for 3 seconds, and after time it turns off automatically. Some people might not like this, but it's a safety. An attacker won't be able to connect to the station via Bluetooth and forcefully turn on the AC outputs. There aren't many features in the app. It shows the charge status and the power of the load in charging. There's control of the outputs. You can choose one of 3 charging modes and turn on. Eco mode. Automatic shutdown of outputs if there's no load. Minimal features. If you have any requests to add features, write them in the comments, and I will pass these requests on to the manufacturer. And now about the USB and DC outputs. The station has 4 USB-A outputs, 2 at 18 watts and 2 at 12 watts. Another nice feature is 2 independent 100-watt Type-C ports. On the 12-watt USB ports, there is only the basic 5-volt protocol. On the 18-watt ones, 9 volts and 12 volts fast protocols were found. On the Type-C ports, there are significantly more fast protocols, including Quick Charge 3.0 and Power Delivery 3.0 100 watts. The Type-C ports are independent, so in total they can output power of 200 watts. This means you can charge 2 powerful laptops from the station simultaneously. The DC output is a traditional 12 volts 10 amps car cigarette lighter socket, and there are 2 5.5 by 2.5 DC ports at 5 amps each. But the maximum total, the total power on these outputs is 100 watts. The voltage on the DC outputs is exactly 12.6 volts. And finally, regarding the noise. Noise is an important parameter, especially when used in residential areas. Right now, the station is off and an inverter refrigerator is running in the apartment. The noise is 45 decibels. If you charge the station in silent mode, the noise will be 45 decibels, which is quite low. It definitely won't disturb your sleep at night. Right next to the fans, the noise is slightly higher, 48 decibels, and when charging at 1000 watts, the noise near the fans is 60 dB. And at night, such noise might disturb your sleep. When charging at almost 2 kilowatts, the noise is about the same. Not the quietest station, but the noise is pleasant and you get used to it very quickly. So it is a little noisier than the quietest stations, but noise assessment is always individual and very subjective. Now, I will show you how it sounds when under load. Right now, it's completely quiet in the apartment. That's 35 decibels. I'm turning on the station and the noise is the same, 35 decibels. The fans aren't running yet, but as soon as you turn on the AC outlets, one of the fans starts running immediately, and you can't hear it. I loaded the station with a small amount of power, connected a mini PC, that's a consumption, something around 100 watts. The noise went up to 40 dB. Right next to the fans, of course, the noise will be higher, 45 decibels, but it's barely audible. Let's load it with 600 watts, and here the noise will be around 50 decibels. This is also quite low noise. At a low of over 1500 watts, the noise is around 60 decibels, which I also consider a completely normal result. In quiet mode, the station charges in 3 hours and charges at a power of 600 W. In standard mode, it takes 2 hours and 10 minutes at a power of 1000 watt. As for turbo mode, I failed the first test. Discharging it on the water heater, I didn't give the station time to cool down, so I saw a red overheating icon, and the station reduced the charging power to 1000 W, so I had to repeat the test. In turbo mode, the power reaches almost 2 kilowatts, and the station charged in 1 hour and 40 minutes. But before that, I discharged the battery to 0%, so for the first 10 minutes, the station charged the battery, with a low current gradually increasing it. And that's also a plus for the karma of the engineers who developed this device. If you discharge the station to 5%, then turbo mode, it immediately starts charging the battery at high power. And I recommend using turbo mode only if you have an external battery or only in case of urgent need. For most daily use, the quiet and standard modes are perfectly sufficient for your needs. To take it apart, you need to unscrew 8 screws from the bottom, 4 on the side, and then unscrew the side panels. The handles are screwed to the top cover with screws, so they also need to be unscrewed, and then the top cover comes off quite easily, and all that's left is to unscrew 4 more self-tapping screws, and inside you'll see a picture like this. First of all, there will be a metal frame, thick aluminum, and the aluminum here is not just the casing, it also acts as a heat sink, and it's already clear that the station is built very neatly inside. The front panel with a microcontroller is a universal panel. It's also used on other models, for example, the R2500 Plus. On it, one microcontroller from Nations was found. These are Chinese microcontrollers. The Wi-Fi and Bluetooth adapter is built on the high-performance 32 Spanish Peseta C3 microcontroller, a voltage converter, and it looks like this is the converter for the 12-volt outputs, and this is 2 voltage converters for the Type-C outputs. The build quality of the station is super excellent. All cables are wrapped in additional insulation, everything is well thought out, it disassembles easily and without any unnecessary difficulties. So the engineers who created the internal design also get a plus in their karma. As for the cells, cylindrical cells from CBAK are used. I've seen the same cells in other charging stations. One such cell can output a current of 60 amperes. Inverter board with a charger, low voltage converter, 4 transistors on a heatsink, AC input and output, and the high voltage section. And notice that for cooling this inverter, 2 small fans are used. On the other side of the board, there are unpopulated connectors for connecting 2 more fans. But for cooling, these 2 fans are enough for the inverter. And that's only because the bottom metal panel on which the inverter sits is used as a heatsink In the power transformers of the voltage booster, stranded Litz wire is used. Such wire is used in high Q inductors. The relay at the output is a 30 amp one. There aren't many protection elements on the AC. Inputs and outputs, there are common mode chokes, excapacitors, and fuses. So if you have an unstable power grid and there could be voltage spikes above 260 volts, then I highly recommend using a voltage relay. The high voltage transistors are common. This is an NCE power transistor rated for 650 volts, 38 amps. MPPT controller transistors are used here, and they are transistors with a current up to 135A and a voltage up to 100V. To reinforce the conductive tracks, metal bus bars are used. Communication between the inverter, BMS, and external batteries takes place via CAN. Under the power transformers, there's additional insulation. The sine wave generation board uses microcontrollers from Nation. The main problem with any portable power stations is precisely the microcontrollers and the firmware, because if this microcontroller burns out, and this can happen from reverse current or from a lightning strike nearby, then the station is difficult to repair. We remove the inverter board and see a thermal pad that transfers heat from the transistors to a large metal plate. 6 transistors of the low voltage converter, and it looks like a push-pull circuit is used here. The drivers for the high voltage section are located on top, and on the right are the logic and power supply units. The voltage booster transistors are also quite common, they can be purchased, and this is a 150 volt 140 amp transistor. 3 drivers for the high voltage section, and the driver here is also a very common SLM2100. The inverter, microcontroller, and again, a microcontroller from Nations is used here. The metal plate under the inverter acts as a large heatsink, so it's no surprise that they only use 2 small fans to cool this system. And under this metal part, you'll find the BMS board. Their BMS is also interesting, and they have long been using transistors in TOL packages. These transistors are capable of handling significantly higher current than transistors in other packages. And on the left, the pre-charge system is assembled using SMD transistors. Just a reminder, when you turn on a portable power station, the BMS turns on first and supplies voltage to the inverter. And so, in order to prevent the protection on the BMS from triggering, a pre-charge system is used, which limits the current used for charging up the capacitors found on the inverter. The transistor in the TOL package is rated for voltages up to 100 volts and currents up to 350 amps. And near these transistors, we also found suppressor diodes. The balancer here is passive. A 47 ohm resistor means a balancing current of about 70 milliamps. The control of the pre-charge system, the charge-discharge switches, the passive balancer, and the battery management controller is handled by the Sinwealth SH367309. This is probably one of the most popular controllers, and it can be reprogrammed, and communication here is handled by a microcontroller from Nations. Again, I want to draw your attention to how everything is done here. The power contacts are covered with an additional film. The power wires go in additional insulation, and there is extra insulation near every connector. Even the insulation sheet that covers the battery pack is cut out for the screws and all the protrusions, and I think that's mega cool. Well, anyway, I truly hope that in this video you were able to see everything you needed to know about this station. If you happen to be interested in learning anything else, then please be sure to write to us in the comments below.